So I'm glad to be here and glad to open up this seminar series in the fall. And I've been now back in Cambridge for about 2 weeks, so I'm almost done settling down here. And I found where coffee is this morning, so that was important. So I'm going to talk today about some recent research that we've done, in the last couple of years, trying to bring machine learning algorithms to solve some interesting problems in social science. So I know that many of you are already working at this intersection of computation and social science. And so that's why I'm really excited to be here, and I would like to discuss with you and collaborate with you in many different ways in the next year and beyond. What's a little bit different about the research that we do is we do a lot of text analysis, whereas I know a lot of computational social science involves social network analysis, which is also great, but we try to do a little bit of network analysis as well, but we're not very good at it. If we do the text analysis, it can bring a lot of richness out of your data, out of the social science or social media data that we work with, and that's what I'm going to try to present to you today. So this is the overview of the talk. I'm going to do just a very, very brief overview of our research and about topping modeling, which is the main algorithm that we've used in the 2 papers that I'm going to talk about today. I'm not going to be able to do justice to topping modeling because it'll be just a couple of minutes of that. I'm going to talk about our ICWSM 2012 paper titled Social Aspects of Emotions in Twitter Conversations, and our ACL short paper titled Self-Disclosure and Relationship Strength in Twitter Conversations. And then I'm going to try to leave a lot of time at the end, we'll see how that goes, to have discussions about what's worked, what's worked well, what are some of the challenges that we've encountered, and maybe I'd like to open up the discussions to you and get your feedback about what you think about all of this. Okay, so a brief introduction to the research that we do in the lab in general can be, sorry, the font is a little small. It can be categorized into two big categories. One is topping modeling or machine learning, and then the second category is computational social science. So in topping modeling, we ask a lot of how questions. How do you do this? How do you model time series data? How do you use meta information in your data? How do you organize your topics into hierarchies? So those are, how do you do the machine learning? That's what we try to do in the first category of our research. And in the second category of our research, we ask these, can we do this using topping modeling? Can we do this using machine learning, SVMs, whatever? So it's sort of applying machine learning algorithms to these problems in social science. And I'm a computer scientist. I didn't have any training in social science. My students are all computer scientists. So we're sort of doing this, probably scratching the surface, not really getting into the deep part of social science, which I hope to do, but we haven't really been able to do that so far. But we ask what we think are interesting questions, like the emotions and social patterns. Can we look at that from social media using machine learning? And that's what yeah. So in terms of papers, these questions actually translate directly to these papers that we've published. This is just to give you, the computer scientists in the room, an idea of where, what venues we're looking at. So the top, if you know the area, it's the AI machine learning community, and then the bottom is more like worldwide web-related, NLP-related conferences. So the two papers are going to talk about these two questions about emotions and about self-disclosure. So I'm going to go directly into first to what is topping modeling. You may have seen this review paper in CACM in 2012. David Bly is at Princeton, and he's a big guy in topping modeling. The key insights that are important, I think, they're algorithms for discovering the main themes or topics or whatever you want to call them that pervade a large and unstructured corpus of documents. So that's important because, in this web era, we have a lot of unstructured data out there. And this third point tells you that they can be not only applied to text data, but they can be applied to image data as well. And we've worked with some image data in our lab as well. And the second point, we've also done some research, which I won't talk about today, but the latest big sort of topic within topping modeling is how do you apply this to a very large set of data? So millions of documents containing hundreds of thousands of words and tens of millions of words in the entire data set. The traditional ways, you really can't do that, but there have been recent advances that allow you to do that. So what topping models do actually, it's a graphical model. I'm just showing it to you just to make it cool, but I'm going to just skip ahead to what it actually does. So if you imagine you have a document collection of, let's say, 1 million documents from the New York Times, in the 100 years of the New York Times, there's all these things, all these topics that are being talked about in that corpus of articles, right? So we want to know, without having a priori selected a bunch of topics that say, the New York Times is going to talk about Obama, it's going to talk about George W. Bush, and all these other things. Without having any prior knowledge of that, can you identify what topics, or can you discover the topics that are within the 1 million documents that you have? Okay, so for example, if you have this article in your corpus, it's going to say, as the output of the topping model, there are 3 sort of major topics within this article. The first topic is about racing, or NASCAR races. The second topic is about economic recession. The third topic is about the general sports topic, right? So the assumption that topping models have is that you're kind of looking at the generative process of an author, right? So if you imagine you're the New York Times article writer or journalist, you're going to write this article and say, well, I'm going to write about these 3 topics, right? So what are the words that are going to come out of my brain and onto the paper when I think about these topics, right? So it's sort of a very naive approach, but it's a good approach to discover what is unknown beforehand, right? And try to find those patterns. And I'm not going to go into sort of detail about what the algorithm and how the algorithm actually does it, but if you think about the entire corpus, what it's going to give you as the output is it's going to give you what are the topics that are in your entire corpus of data, and for each of the articles, what is the topic distribution? For example, this article is half or 50% about the NASCAR racing, whereas this other article is about the Red Sox, so it's mostly about this sports topic, and then the top article is mostly about the economic problems, right? So, and if you notice, some of the words are colored with the colors of the topic, so it's also going to give you for every single word in your corpus what topic it should belong to, or what topic it was generated from. So that's a 2-minute summary or 5-minute summary of what a topping model does. And you will see sort of how we apply this to things like emotions, right? So this work was done by my student who's now a Ph.D. student, and he was a master's student at the time. We had we somehow got interested in how people have these conversations on Twitter. So if you notice, a lot of people use Twitter in different ways. Mostly, I use it to browse the news, what my friends are up to and stuff. But a lot of people use it as a personal communication platform. So just like you're texting, you use Twitter to have these conversations. So this is an example of a conversation that I had. So Alice O is me. I just, said our paper is published, and this other student at KAIST at the time, can you give me a paper? Can you give me the paper? And then I reply. And so this is the type of conversation chain that we're looking at, and we've collected a bunch of those. So there's a lot of motivations for doing this. The major motivation is that you can really observe this, how people have conversations in this natural setting, right? So this is a corpus that is not easy to get elsewhere, right? So you can't have transcripts of text messages, right? Because there are a lot of privacy issues. You can't get access to Facebook direct messages, or even you can't get direct messages from Twitter, but a lot of people do this by just writing public tweets. So that's what we thought was pretty cool. We now have about a million dyads and all of the conversations that they have. A side effect of crawling Twitter this way is that you get rid of a lot of spam. So working with Twitter data, I don't know if many of you are doing that, has the big problem that you have a lot of spam accounts, a lot of spam messages, and how do you delete that so that you can do real research on good data, clean data. So this is one way. So then we have all this data. What are we going to do with it? What kinds of research are we interested in doing? So we said, rather than just saying, well, let's look at the length of the conversations, let's look at what are the topics they're talking about, sort of ad hoc, right? So we wanted to ask these questions that maybe social scientists are interested in, but they haven't had a big data to work with. Can we try to, take a research question from the social scientist perspective and try to do it with our data and with our data analysis tools? So there's and notice it's not sociology because we don't really work with network, how people are linked, but we look more at the conversation data itself, the content of the conversations. So there was this research in organizational behavior called Emotion Cycles on the Social Influence of Emotion in Organizations. And OB people, they look at how people work together, right, in groups. If you imagine 5 people having a meeting, what are the emotional exchanges within that meeting? What are the cycles of emotions that go on, and how does that influence performance or something like that? So, the abstract of that paper had this little bit. We proposed that organizational dyads and groups inhabit emotion cycles. Emotions of an individual influence the emotions, thoughts, and behaviors of others. That's pretty obvious, but they're doing. But it's hard to. Hard to understand and analyze exactly what's going on in these emotion cycles, right? And they have been looking at, I guess, they do research on a small scale. So you can imagine bringing in 5 people into your lab and having them, have a conversation, and you can do analysis of that transcript. So we can do that, but with a million dyads, right? Or 220,000 dyads that we have in our conversational data. So that's exactly what we did. So the first question then is going to be, how do you analyze emotions? How do you know that if I say, oh, I'm having a great day, then that's happiness or joy or whatever you want to call that emotion, whereas I'm feeling really sad, I'm depressed, then that's a sadness emotion tweet. So we want to do that automatically, right? So because if you have a million tweets, you don't want to be hand tagging. So there is where you can apply machine learning, as you can imagine. And topping models find these themes in your corpus. So a theme, if you apply the topic is an emotion, that analogy, then maybe you can find the emotions. What we found with the basic LDA that was lacking is that you can't put any sort of prior knowledge into LDA. So LDA is the basic topping model, and it's not really good in the basic model to handle prior knowledge. So what we found is a topping model with a twist. It's called the Dirichlet-Forest prior, where you can, it's sort of like, if you know clustering with constraints, it's doing clustering with constraints, saying like these, I'm doing clustering, unsupervised learning, but I'm going to say A and B have to always be in the same cluster, or A and C can never be in the same cluster, right? So you can do that with this, with the topping model. So let me show you how that's done. Oops, sorry. So this, for example, if you can imagine somewhere you got a list of words that should belong in the category joy, a list of words for sadness, for all of these emotion categories, then you can say, well, these words should, I don't know which cluster, but they should always occur within the same class, within the same cluster. Whereas, for anticipation word and surprise word, or any pair of these different emotions, joy and sadness, they should not be in the same cluster, right? So it's sort of doing, working with these general seed words and putting that into the topping model. So then, using those seed words and using this model called Dirichlet-Forest topping model, we come up with this list of topics for the emotions. So what it's doing is it's looking at all these tweets, starting out with tweets that have explicitly these keywords in them, like I'm feeling sad, right? So sad, that's a sad tweet, but it's going to also have other words in it, I keep crying or something like that, I can't stop crying, then the cry word also gets into the sadness topic, right? So then what you can do once you've identified this hurt, good, bad, I don't know why good is there, but hurt, bad words are in your tweet, then you can identify that tweet as a sadness tweet. Okay. So let me show you some examples of how the conversations are tagged. So here are two examples of the conversations. So you may wonder about what are these emotions? Are we using the emotion categories well? Love, sadness, is the first tweet really love? If you read it, it's more like hopeful, or not really hopeful, but sort of, I don't know, empathy or something, or sympathy. So anyway, that's another question. How do you come up with these emotion categories? But anyway, these are if you look at the tweets, the sadness tweet, extremely sad, that's a typo, but it's a typo in the original tweet. So that's what the model does, right? So this is the bit that's automatically done. All of the conversations, all of the tweets in the conversations are annotated automatically with the emotion categories that the tweets should belong to. Okay, so that's the first, yeah.
A quick question, and maybe you said this, I may have missed it. How do you determine which words correspond to a particular category, or did you just select those?
Yeah, I didn't tell you. So the seed words that I showed you come from a book called I Feel Fine. Do you know, it's a book based on blogs and where people write, I feel sad, I feel whatever. And then they have hand tagged those words into these emotion classes. So there's about, I'd say like 25 words for each emotion category. And so we use those to bootstrap. And so the rest of the words are found automatically from the corpus. Yes? Negation. So we don't. We do like simple negation and processing. So yeah. So we do simple sort of pattern matching negation analysis. So I didn't talk about the whole pre-NLP processing step. There's some things that we do, but those are, you can think of them as technicalities that all NLP researchers do. Yeah.
A lot of time words that could be like agreement.
Definitely. Right, right. So negation in NLP, if you really want to do it right, that's a really big problem, but we do a very, very simple pre-processing step to account for negation, yeah.
What is the motivation for clustering? Why not just use the initial topic that you start with? You already have words that are categorized into sadness and surprise, etc.
So you mean like these words?
Yeah, why
because
not go with those topics?
because a lot of tweets that are expressing sadness, for example, don't necessarily contain these
We want to
words.
grow the class.
Yeah. Yes.
Do you do any checking of the classification tweets with like human?
Yeah.
To see would a human classify?
Yeah, Right. So we did classification. The results are not very good. So that's why I'm showing the classification accuracy. So these are, we're working with 8 classes. So accuracy is for us is about 40% or so. So that's really bad. So we need to do it again. So here in this paper, we've sort of outlined how it's done and what you could do. So emotion analysis, since then has improved a little bit, like using hashtags on Twitter and stuff. So that recent work, we're going to try to incorporate it into ours as well. Yes?
Yeah, what about like ambiguous words like this is sick? And what about like mixed emotions?
Yeah, so the second question, mixed emotions, so we have sort of variations of our model. One of the models is to allow multiple emotions per tweet. So, but that becomes even harder because the accuracy is going to go down even more. And even if you have humans hand tagging these emotions, they don't really agree always. So it's sort of a, it's sort of a big problem. With ambiguous words, a lot of times what we would do is just then, if you can't really say if it's A or B, then we would just say we don't know or tag it as a neutral emotion, just for this research. If you see the rest of the research, you'll see how the results of this tagging can work even if you don't have like 90% or 80% accuracy. So let me show you the rest. So we wanted to see these emotion transitions. So this first figure, what it's showing you is a very simple transition probability of A's emotion and B's emotion. So if I'm A and I say something like I'm sad, with 19% of the time I'm also going to say that I'm sad too. But then 30% of the times I'm going to say I'm happy. It seems pretty counterintuitive. One reason is that a lot of the tweets are just classified as joy. A lot of tweets just are sort of like the shallow, happy, let's be happy kind of tweets. That's the nature of the data and also the nature of our algorithm as well. So there's some flaws in the algorithm. Anyway, but if you ignore the huge parts going into joy, you'll notice the biggest transitions are self-transitions, meaning if I express anger, you're also going to express anger. And that's sort of an obvious finding, but it's interesting that we found this using this Twitter huge amount of data and this algorithm that only has 40% accuracy. Right? So let me move on to what's even, what we really wanted to do is this notion of influence. So if your partner is feeling sad, what are you going to say to make that partner not sad or happy? Or, if you want to anger your partner, what are you going to say? Right? So we look at this chain of tweets. User A says something like, I'm sad. User B says something, and then user A changes his emotions. So every time there's a change of emotion occurring within one person, what is it that what is the intervening tweet that has caused that chain, right? So, and we call that the emotion influencing tweet. And we looked at these emotion influencing topics, basically, right? So if you look at this, the middle column, a lot of swearing going on in our data. So a lot of our data come from high school kids, college kids in the US. So if you swear at somebody, that person will get angry. It's kind of obvious. If you complain, it's not really sadness, but the categories are a little bit weird. A lot of greeting or sympathizing going on, turning somebody to be a little bit happier and so on. So we thought that was pretty fun. So if you look back at conversations, you can see, for example, you can see things like, so we were looking at these things, right? So A goes from anger to love, or to more like an okay, positive emotion. What is it that this person has said? What is the topic of that tweet? Okay, so that's what we were looking at. So, yeah.
How many distinct posts do you have in a conversation? Like you're trying to determine whether a particular post is going to influence something,
Yeah.
influence an emotion.
Yeah.
Do you have actually multiple posts that are actually related, and there is a chain? Do you find enough of that?
So, well, that's what we should look at, but we didn't look at that at all. So we just looked at sort of exactly one tweet that is between two emotions. So, so we didn't say, so if this was also anger, and somewhere down here, A turned from anger to love, right? Did we look at all those things? We didn't. So we looked at just the immediate tweet beforehand. But what you're pointing out is really great, because now we're developing a model that actually looks at the entire chain and looks at the maybe like it's still like a Markov chain, but what happens within the entire chain of conversation as far as the emotions being influenced. But we haven't done that yet. So that's I think that's. So another interesting part is that when you look at these influencing tweets and their emotions, so if you want to make somebody to feel joy, then you're going to, if you're going to make A to feel joy, then B should say something joyful. Then that has the highest likelihood of making that person joyous. And the same thing with anger, with all of these emotions, right? So if you want to make somebody fearful, then you should also say something that you're being fearful, and so on. So so you can see that we're using this set of 8 categories of emotion, and they come from this thing called Plutchik's Wheel of Emotions. And we tried to take that from social psychology, but a major question that we have, and we've actually experimented with different categories of emotions, is the basic set of emotions that people have. Are they going to be expressed in sort of the same way online in these Twitter conversations? Are there inherent differences between sort of face-to-face emotion exchanges and online exchanges of emotions? So these are all sort of more deeper questions that we haven't really looked at yet. So I'm going to, with that, I'm going to just move on to the next paper. Yeah, so we can talk about the emotion stuff later on as well. This was using the same data set that I showed you, but looking at self-disclosure behavior. So the motivation for this research was that we were looking at how people become closer friends, right? So, but then, and in becoming closer friends, there's this notion of disclosing your personal information, right? So strategically, you're going to reveal more about yourself if you want to become closer friends. Like, I live here, where do you live? I went to MIT, where did you go? And so on, right? So we wanted to see if we can see this kind of behavior patterns in Twitter conversations. So we wanted to see, so we didn't do time series analysis with this research, but we're planning on doing that. So we just looked at dyads with high relationship strength, or closer, and I'll explain how we define that, whether they show more self-disclosure behavior than with dyads with low relationship strength. Okay, so let's see how we did that. The same Twitter data, a little bit smaller. And we defined relationship strength to be, we tried several different things. We looked at network centrality measures also, but it turned out that our very, very simple definition of relationship strength worked the best. Chain frequency, so how frequently they talk. And when they talk at one time, what is the length of the entire conversational chain? So those are the two relationship strength metrics we looked at. For self-disclosure, so the social science literature, the social psychology literature defines self-disclosure in sort of different ways, but what we found is personal information and openness of communication. So, so let me tell you about this. So personal information is personally identifiable information and personally embarrassing information. So if you know Dana Boyd, she talks about this in one of her earlier papers. So you can imagine personally embarrassing information is like, you know, I got an F on my test. I lost my job, things like that. I had some kind of a medical test and it turned out to be whatever. So those kinds of really private information that are not PII. So PIIs are things like your location, your birth date, your email address, your phone number, and so on, right? And then there's this whole thing about open communication. So I'll talk about sort of different categories of open communication. Negative openness, so if you're close to somebody, you're going to say more negative things because you feel like you can. You know, I lost my phone, and that's an example. And to analyze the negative openness, we used a model called AWESOME, which is Aspect and Sentiment Unification Model. This is another topping model with sentiment analysis in it. So sentiment analysis meaning positive or negative, right? So obviously, I lost my phone. That's going to come out as a negative. Well, I mean, it's not really negative per se, but it's negative with respect to what's going on or how the speaker is feeling, right? So it's a topping model that classifies automatically the polarity of each tweet. Okay, so that's what we did. There's nonverbal openness. In face-to-face conversations, it's usually like how much you gesture, how much facial expression you use, and so on. Here with the tweets, we just use the emoticons and LOL and XXX. If you use Twitter, you should know what those are. So that was an easy thing to do. Just look for those patterns. Emotional openness. So we're looking for tweets that contain emotion words. So the set of words that I described to your question, sorry. We Feel Fine has a list of emotion words that people tend to use a lot in blogs, so we use that. And then this part was the hardest. How do you automatically identify tweets that contain personally identifiable information? And even more difficult is this. How do you identify tweets that contain these embarrassing or personal information? So for this, we used topping models again. And we tried different things. Like we tried SVM classifier with keywords. We tried sort of HMM style pattern recognition, I think. So we tried different things. And then in the end, we just said, well, let's look for topics that tend to contain these personal information. So, for example, where do you live, or I live here, or I went to school, whatever, university. Those are going to be identified as topics that contain personally identifiable information. Oh, let me actually show you. I have the results. So, live, all of these location names. There's a bunch of location names. So each column is a topic. So this PII1 means it's one of the topics that identifies a tweet as containing PII. So to nighttime good. So this is like I'm going here tonight. I'll be in San Francisco tomorrow. That type of a topic. You can see how these can be personally embarrassing. So like clinical information, your family type of information. So these three topics contain, or if your tweet contains these words, then that tweet is very likely to be identified as PEI. So what we did is we did this on Mechanical Turk. We sent out thousands of tweets, and we asked the Mechanical Turkers, do these tweets contain personal information? And we did topic model training based on that. Okay, and we also looked at profanity just because there was a lot of profanity. So the results, let me show you. So remember, what we wanted to find is this relationship or correlation between relationship strength and self-disclosure behavior, where self-disclosure is either PII, PEI, or this open communication pattern. So these are the two, chain frequency and conversation length. Those are the two x-axes measuring relationship strength. And then for each of these graphs, we're looking at sentiment, so negative openness, or negative and positive and neutral openness, nonverbal openness, emotional openness, and so on. So let's look at, for example, the top left graph, and you can see that positive, so negative openness was saying as you get closer to a person, you say more negative things. Okay, so you can see the red line is the negative openness, and it goes up, meaning as you get to a strong relationship, you're going to be open more negatively. And it's the same thing with some of the with the nonverbal relationship, nonverbal openness. So you're going to say more of the XXX, more of the LOLs, and more of the emoticons as you get closer in your relationship. Profanity also. So with your close friends, you use a lot of profanity words. And here you can see for embarrassing information like your clinical history, your family problems, you're going to say more of it as you get closer in your relationship. But there are some exceptions, so I'm just going to show those here. You can see that personally identifiable information actually goes a little bit up and then down as you get closer in your relationship. Okay, and I'll explain how, by example, why that is, and then and some of the emotions as well. So a lot of joy being expressed, a lot of sadness, or relatively. So joy, it's the sort of the biggest exception. There's a lot more of joy being expressed when you're not very close in your relationship. So let's see how that is. So it's all because of sort of this, you meet for the first time on Twitter to have a conversation, and you just kind of open by saying, I saw the picture of your dog, he's so cute, or I saw that you have a 1-year-old daughter, she's so adorable. So a lot of these sort of joyful exchanges occurring. And then the interpretation about personally identifiable information also it was kind of surprising to us, but a lot of people, they open the conversation by saying, I live in Cambridge, where do you live? So you would think that these are all public messages and they would care about privacy, but a lot of people don't. So that was one thing that we found.
But also, if we're very close, then we probably know.
Yeah. So that's a whole set of questions that we should look at, right? So what are we? So we're only looking at their online interactions, right? So what are they saying offline? That's a problem with using Twitter conversation data. So we'd like to explore that more, maybe augment it with interviews of people, other things. So what was interesting also is looking at outliers. So sometimes you would see a pair, a dyad, has only a couple of interactions. So they have maybe 1 or 2 conversation chains in our 3 years worth of data. But they talk about really sort of sensitive things like, this one, their parents are having a fight over whatever. So we were wondering what is happening, right? And there are a lot of outliers that show risky behavior as well, right? So what are you doing tomorrow night? Let's meet somewhere. And so that is one area where you can kind of see application areas, right? So maybe some security alert or something like that. You shouldn't be saying those things online. But we haven't done that kind of application yet. But we thought that outliers like this were kind of interesting. One of the social scientists that we talked to said this is actually pretty natural because a lot of people have these stranger on the train kind of conversations where you meet a stranger on the train, you sit next to him, and you just kind of pour your heart out because you know that you're not going to see this person for the rest of your life, or you almost know, right? So people having these really private conversations on Twitter, and some of them I can't even show in a presentation like this, but it's really interesting. So we'd like to share this data, or actually, we're not supposed to say we're going to share the data because Twitter has this policy, but we can share the tweet IDs at least of these conversation data. So in this research, we looked at a large corpus of conversations and trying to sort of correlate relationship strength with self-disclosure behavior. Do people really disclose more when they're closer? And it looks like they do. So I'm pretty much done with describing the 2 papers, and I think I'm doing okay with time. So I just want to open up the discussions then. Maybe I'll take some of your questions and I'll ask you questions about how to do this better, right? So I thought, what we did was it was really interesting to us that you can actually use these really simple machine learning methods to look at these interesting phenomena in text, and especially conversational text. But one of the things that we really struggled with, and we still struggle with, is how do you find the research questions, right? Because these research questions, like self-disclosure behavior, emotion cycles, they came from social science research. And I think I like it that way, rather than us just kind of coming up with some questions when we're not social scientists, and we don't know what questions are important to them. But the limitation is that they should be simple questions that we can answer as computer scientists. We can't really look at deep social science questions. They should be simple, but they should be important questions, right? So I think the emotional exchange was a really good question because it's intuitively it's a simple question, but it's difficult to really try to answer well. But the computational methods and this big data that we have can try to do a little bit can look at the question from a different angle, different perspective. So we don't claim that we're better than social scientists in doing this, but we have just a very different perspective on how to get at this question, right? And not only that, they should be answerable with the data and the methods that we have. So a lot of social science questions, I'm sure they're very interesting, but we don't have the tools to answer those, or we don't have the data to answer that. And the data is actually a really big limitation. The Twitter conversation data is great, but it's only great for a very small set of questions. There's a lot of questions that we'd like to ask, but we can't ask, right? So like categories of emotions. So we looked at the Plutchik wheel of emotions. There's like a 3-dimensional thing. There's hierarchical categories of emotions. All these things that social scientists have already found their research results for. But then when we try to borrow them to look at social media data, they don't quite fit, right? So fear, for example, you don't see a lot of fear being expressed on Twitter. Instead, you may see like being worried is a big category that we didn't find in that 8 set of emotions. So what is the right categorization of emotion or anything else that we need to borrow from social science to use, how do we kind of tailor it to fit our data, fit our models? The use of machine learning. So I went to Gary King's talk last week, and he was saying, how machine learning doesn't work. I mean, there's some truth, or there's some, agreement. I do agree with his sort of, lack of trust in machine learning methods, which is why it makes it more interesting for us, right? Because there's a lot of room for improvement. So like what I talked about, the Dirichlet forest prior, it may seem pretty simple to some of you who don't know the LDA literature, but it's sort of hidden within that literature. Not a lot of people have used it, but we found a use for it and said, this is a better model than just the simple LDA. We may actually have to come up with new models that are better fit, have better assumptions for those social science questions that we're trying to answer. So how do you use that, and how do you redesign or even come up with really new machine learning algorithms that can really try to solve the social science questions? So to end the talk, I'm really looking forward to collaborating with you, just talking with you. I don't have any classes to teach. My students are all away, so I mean, I do Google Chat, but most of the time they're not here to bother me. So I have a lot of free time to talk with you and share data, share algorithms. I'm happy to share what I know about topping modeling and other machine learning algorithms and how they can contribute to whatever problem that you're working on. So please do email me or come visit me here. All right, thank you. Yes.
So these tools that you built, you worked on a certain profile of data from Twitter, trying to address specific social questions. And have you tried to either sub-stratify your cohort to find, say, differences in the result between sort of this class and another class? Or, for instance, in your case, you said you used American, US.
Yeah.
So I say using Korean versus American.
Yeah.
Yeah. Results change. I mean, that would be I guess of interest to social science.
Sure, definitely. So I noticed, so I've been talking to a lot of, some social scientists since I started working on this, and I noticed that something that we overlook is the population of our data, right? So our Twitter data contains, 15-year-olds to 65-year-olds, and people from England as well as US. I mean, we use English data, but a lot of them are in Australia or England. So we need to look at that. We haven't really, with this work, we haven't. We did some work with Facebook, personalities and things like that in Facebook, and there we looked at Koreans versus Americans, actually. And it's a little bit harder to do with Twitter because you don't have all the profile information, but it's certainly something that we should definitely do, yeah.
So I have a question. So like I'll carry the banner, social science, for a little bit. So like the gold standard and for like causality and these sorts of things, so the behavioral studies would be like to do like a random assignment experiment. So I was wondering if you thought about anything around like if you could have a Twitter bot, or if you saw these conversations were unfolding, that Twitter bot could sort of jump in and say that like something joyous or sad based on whatever sort of model it was. And have you thought about like how you could build a system like that as an intervention, or do these sorts of algorithms, are they sort of, can you run them fast enough where you could put them into the stream and they'd able to do these things and participate in these conversations?
Yeah, that's a great idea, and it is certainly you can actually do it real time. I mean, and yeah, it's something we should do. That's great. Yeah. Yes.
One idea, I say it's not my idea, so I can say it's a nice idea. I don't think too embarrassed. There was a paper this summer, I don't remember if it was on Facebook or Twitter data, but they were classifying like embarrassing tweets, messages, by analyzing the time interval they were deleted after post.
Oh, really? I haven't seen that. Okay.
Access to the actual data of the deleted messages.
Oh, okay. Yeah, that's cool. Where was that done?
I think it was the ICWSM, I don't remember.
Oh, okay. I do look at ICWSM, but I haven't seen that. Okay, that's great.
And the other thing is, it is kind of surprising that when people get closer, like they have stronger ties, they will disclose more because it seems public. It's kind of a privacy illusion.
Yeah. I think there certainly is privacy illusion because these tweets, even though you can see them, they're not visible on somebody else's timeline, right? So just because I'm following you, I'm not going to see all of these tweets because it's only when you're following both people that you will see on your timeline. So I mean, we have to do some kind of an interview to verify that they have this privacy illusion, but I think there certainly is that going on. Or either that or they just don't care. Yes?
You made, on this privacy point, you made some references on Facebook policy that says that you can't share your data.
Twitter has that policy, I think, yeah.
Sorry, Twitter.
Yeah,
Yes,
yeah.
So, I mean, I thought you collected the data because these are public tweets.
Yeah, so I think the policy is like you can collect the tweets, but you can't say, well, I have all these tweets that I've collected, let me give them to you for your research. But it's ironic because you can give them the tweet IDs, and that's what people have been doing because there's like ICWSM, for example, has a gold standard data set that they annotate and stuff, but they can't actually give out the tweets. They can only give out the Twitter IDs, and you have to crawl them again.
And is there any process about when someone can collect the kind of tweets, or you're free to?
So you're free to crawl the data. I'm pretty sure. Yes.
It's under profanity. What does IMAO mean?
LMAO is laughing my ass off. Yeah.
That's one of the classes.
Yes.
Is there a way to begin to learn about trust relationships from your method?
Trust. You mean like I trust you, so I'm going to say, well, where I will be next tomorrow?
I was thinking a little bit about looking around something you said you looked at them and you didn't end up using, but right, so there's all this work on trust graphs and computing scores for how I trust you based on how connected I am in a social network to you, etc. And generally it's very useful for lots of applications to understand how trustworthy I think you are and how trustworthy you think other people are. And I'm wondering if we can look at, from the dialogue that we're having, we can try to unpack things that we might miss if we just look at the length of a conversation.
Yeah.
And try to get below that and really understand trust.
Sure, definitely. So yeah, I mean, I think it's an important direction. And my gut feeling is that you can do text analysis to try to reveal trust relationships. But how would you verify that? Like, how would you know, I'm having this kind of conversation with Greg and I trust him? How? I guess you can have, I guess you can ask people, like, do you trust him? And do you trust him for whatever?
But instead of trust, you could be looking at promiscuousness in terms of online interaction or something like this as a proxy. I find, for example, the PEI to people they don't know very interesting. And those are the people I probably don't want to friend, right? In terms of, proxy for whether I would find them trustworthy.
So you mean like if I reveal something embarrassing, then I shouldn't be your friend?
Lots of people.
Uh-huh.
If you reveal lots of embarrassing information to lots of people, then I probably don't want to trust you.
Oh, I see. So it's not that I reveal something because I trust you. It's more like if I reveal a lot of things, are you going to trust me? So we haven't looked at that angle. But that's, to get back to what you were saying and what I was sort of responding back about, how do you know somebody trusts somebody else? There's the CSCW community does a lot of sort of interview-based research about these kinds of things. Like, so they identify a lot of people who would have conversations like this and say, would you trust this person to lend $100 or to reveal your current location every time and things like that. So I thought something like that would be really interesting to do, and I think at some point we might do that. And there's another thing that I've been thinking a lot about with the influences. So we looked at emotional influences, but people look at influences in different domains. So like if I'm really close friends with him, he's going to influence me in my research, but then he's not going to influence me in my taste of music, for example, or politics. So what are the domains? What are the topics that they're talking about, and how does that translate to influences in different domains? Yes.
Is it possible to get sort of demographic information from these Twitter users? And
Yeah.
like the traditional social science for like their race, class, et cetera, but also maybe that account of sort of
Yeah. That's the direction that we should go. So I have a grant that does actually, and I should be working on it. So that's, and we are working with social scientists. What's easy to do is gender. So gender is, they would say with English tweets about 90-some%. You can identify females and males. But anything else is really hard to do. So geographic information, for example, there was results from CMU. They said the average error of distance is like 500 kilometers. And we were looking at Korea, and like 500 kilometers, that's like South versus North Korea. With age information, you can probably do like 35 and below, and then like 35 and above, or I guess I'm in the above category, but so maybe like 40 and below. But you can't really do like 20s versus 30s, and that's what. So whenever I look at social scientists, they say you should really be able to say the 20s versus 30s versus 40s, but at the moment, I don't think we can do accurate classification that way.
That's a one question. Is it possible to combine network analysis with topic analysis?
Yeah. So that's what we should do, right? So you can do, for example, in the network, instead of having links, and now they can have some, Yuri Leskovic has talked about having sentiment Latin links, like positive link versus a negative link, but you can have topical links as well. There's a link between these two people, but these are the topics that they talk about, or with weights or something. That's one way to do it. Then you can do network analysis, finding your communities, finding the hubs, whatever. We're looking at different ways of doing a combination of the two. Okay, that's great. All right.
We should wrap up. Thank you so much, Alice.
Yeah, if you have more questions, we can talk later. Thanks.